our notes for the sections for 2.1 and 2.R.5. They both have the same basic ideas to them, and 2.1 is pretty short, so a lot of it's going to be included in this. So first, so these are graphing. So we're graphing on the Cartesian coordinate system. So first we need to remember what an ordered pair is. Okay, it looks like this, with parentheses separated by a comma, where we have some type of x value and some type of y value. So an ordered pair is basically a solution or something that satisfies an equation for a graph. So like for example, if we have y equals 3x plus 1, okay, and we want to know if 2, 7, the ordered pair, satisfies this equation. Okay, so basically to find that out, you substitute your x value and your y value into the equation and then see if it makes a true statement. So this is our y and this is our x, so our 7 is going to plug in right here and our 2 is going to plug in over here. So we'll have 7 equals 3 times 2 plus 1. Okay, meaning we can get this by itself already. 3 times 2 is 6 plus 1. 6 plus 1 is definitely 7. So yes, this definitely satisfies that equation. Okay, but let's say you wanted to find out if the point 2, 0 satisfies it. So we can do the same exact thing, plug in 2 is our x, 0 is our y, so 0 equals 3 times 2 plus 1. 3 times 2 is 6 again, plus 1, well that's 7, does not equal 0, so this one's a no. Okay, so you've got to determine that just by plugging the numbers in. You can also determine missing points from this. So let's say we want to determine the missing coordinate for the equation 5x plus 2y equals 5. And the missing coordinate would be -5, and we're missing our y value. So one thing you need to remember is that the y value is right here, our x value is right here. X comes first, y is second. So you need to remember that to be able to know which one you're plugging in where. So we only have the x value, so you can plug in x and use what we've done in the past with our solving equations to be able to find and isolate the y to get what we need for that. So all we're going to do is plug in -4 for our x. So we'll have 5 times -4 plus 2y is going to stay the same, equal to 5. So we can't plug in both of them. We don't know where y is. Then we can figure this out by solving for y. So 5 times -4 is going to be -20 plus 2y equals 5. We can add our 20. 2y is going to equal 25, and then we can divide by 2 to get our y. So 25 over 2 would be y, meaning that the entire ordered pair would be -4 and then 25 over 2. Okay, so they may ask you to put in the whole ordered pair, they may just ask for what the y value is. Some of them also have multiple steps, so like this one could be step 1, and then they could give you a step 2 where they're asking you to find the other side. So like this would be step 2 where they want to know the same equation, 5x plus 2y equals 5, but they want to know the x value. So same situation, You need to know that this is your x and this is your y, but now we have a y to plug in here. So instead of plugging in for x, we'll plug in for y, where that 2 is. So we'll do 5x, leave that alone. Y is going to become 2, so 2 times 2 equals 5. Then simplify like we did over here. So this is 4 plus our 5x equals 5. Follow our steps, subtract to the other side. 5x equals 1. And then divide by 5. So x is going to be 1 over 5. Meaning the point would have been 1/5 and 2. Okay, so that's the basics of finding the missing points. Now let's look at these things on the actual graph. So this is our coordinate plane. So it looks like this. Okay, where you have some tick marks showing the values. Same thing going this way. And then here. So these would be representing different numbers. Okay, so the way that this works, it's split up into 4 quadrants. So you do need to know where the quadrants are because it's going to ask a couple of questions about what quadrant is this point in. So if we have something up here in this corner, that's considered quadrant 1. Okay, and in quadrant 1, all the values are positive. So we have a positive x value and we have a positive y value. So both will have to be positive. For example, let me just label some of these out. So 1, 2, 3, 4, 5, this would be positive 5. 1, 2, 3, 4, 5, this would be positive 5. So the way that it works, your horizontal axis is your x-axis. Your vertical one is your y-axis. So all of the values on this side of the x-axis are positive. All of the values on this side of the y-axis are positive. Meaning if we're following the pattern where the first value is x, the first value is y, if we find a point 1, 2, 3, 4, 1, 2, 3, if we find a point like right here, the ordered pair would be positive 4, which is the x value first, positive 3, the y value second. So both of the values are going to be positive in that place. Okay. The only place that doesn't have like a positive or negative aspect to it is the center. So the very center, remember that's going to be 0, 0. That's our origin. So there wouldn't be have any negatives or positives right there. Then we move over to the left over here to get into quadrant 2. So in quadrant 2, we'll have, now switching over to this side, x's are going to change signs. So the positive x's are over here, that means the negative x's are going to be on the left side. But we're still at the top, so these values are still positive, so you'll have a negative x and a positive y. So let's say we have a point here, negative 2 and up here 5. So that value would be negative 2, positive 5. Okay. We switch down to the bottom right here. This one would be quadrant 3. Now we're going to have moving left and we're moving downward, so both of the signs are going to be negative in this case. The left side is our, so 1, 2, 3, 4, 5. This was our left side to be negative x's. 1, 2, 3, 4, 5. This was our going down now to be negative for there.